Okay, we are on lesson 2.5, transformations of functions. So we're going to go ahead and start with graphs of common functions. So it is essential to know characteristics of the seven functions graphs of functions that are frequently encountered in algebra. So there are seven of them that you should know. These are called parent functions that we're looking at. We haven't shifted them anywhere. We're going to look at the shifting after we look at the seven basic functions first. So our first function is going to be f of x equals c, which is the constant function. Um, so here's the graph of the constant function. And the domain of this function, if you look at it, it keeps going and going to both directions for in the domain, so x values. So the domain of this function is negative infinity to infinity. We can also say that it is all real numbers, and we can mark that with the R. So that's a, let me write it better. So it's an R with like a double line on the, that's not good either. um, on that vertical line that when we write in capital R. So there's like a double line for it. Okay, the range of this function is going to be whatever C is. This function is constant on negative infinity to infinity. It does not increase or decrease. And this function is even. If you, so that was lesson 2.2, where we looked at the even odd functions. Okay, next function. This, the graph is right here. And that one is f of x equals x, which is the identity function. Now, if we look at the domain, the x values keep going and going to both sides. So it is going to be negative infinity to infinity. Same thing with the y values. So the range is from negative infinity to infinity. And the function is increasing. It is going up from left to right on in the interval negative infinity to infinity. And this function is odd. Okay, next one here. The graph is this right here. This is f of x equals absolute value of x. So this is the absolute value function. Oops, value function. So the domain of this function is going to be negative infinity to infinity. It keeps going and going, you know, towards negative infinity and infinity, or the x value keeps going and going. The range of this function, so y values start at 0, 0 is included, and it goes all the way to infinity. The function is decreasing from negative infinity to 0. It goes down from left to right until 0, and increasing 0 to infinity. And this function is even. Okay, our next function um, the graph is this function right here, which is f of x equals x squared, and that is a standard quadratic function. The domain of this function is negative infinity to infinity, so all real numbers. It keeps going and going, even though it doesn't like it looks like it slows down on the where it's going on the x, like the x values are going, but it does keep going until it like as long as we would be graphing it. The range starts at 0, and again 0 is included, and the y values keep going to the positive side, so it goes all the way to infinity. This function is also decreasing. So left to right, it goes downhill from negative infinity to 0, and then it increases from 0 to infinity. This one function is even. Okay, next function looks like this right here. And that is a square root function. And you can see that it starts, the x values start from 0, 0 is included, and it goes to positive infinity. It's only in the first quadrant. The range of this function, again, it starts from 0 and also goes to positive infinity. And this function, if you look at left to right, it is increasing from 0 to infinity, and the function is neither odd or even. Okay, next one. The graph looks like this. This is f of x equals x cubed. So that is the standard cubic function. And if we look at the domain, it is all real numbers. The range is all real numbers as well. There's no restrictions. This function, when you look at it from left to right, it does keep increasing. So it is increasing from negative infinity and infinity. There is kind of a little bit of a flat portion, but it's still increasing slightly on there. And this function is odd. All right, next one. The graph looks like this, and this function is the cube root of x. So it is the cube root function. So this domain keeps going, again, um, from negative infinity to infinity. So it is all real numbers. The same thing with the range. And then if we look at the increasing, decreasing part, it keeps increasing from left to right. So it increases negative infinity to infinity. And this function is odd. Okay, so these were the parent functions. Now, what we're going to go ahead and do is look at shifting these functions. So we're going to start with the vertical shift. So let f be a function and c a positive real number. The graph of y equals f of x plus c is the graph of y equals f of x shifted c units vertically upward. That is that plus c right here. If we have f of x minus c, that means that we are shifting the f of x c units vertically downward. So if we look at an example of the vertical shift, and when we're looking at the vertical shift, we do start with the parent function. So our parent function is the absolute value function. And we already had it graphed. We can also just graph it right here. If you're not sure, use the table. You can always, you know, plug in the points. Actually, y equals absolute value of x. So if we do 0, your y is going to be a 0. If x is, actually, I should do it this way. -2, -1, 0, 1, and 2. We did the 0, 0. Okay, let's look at -2. Absolute value of -2, we're dropping the sign, is 2. So -2 and 2 is right here. Absolute value of -1 is a 1, which is here. And then absolute value of 1 is 1, and absolute value of 2 is 2. So there we go. Let me grab the ruler over here so that I can get somewhat of a straight line here. No, where's my rule? Let me, I don't know if it's easier. Oops. No, it went too far. A little bit more. Come on. It is not wanting to. That's not a really perfect line. Okay, well, we'll live with it. So that is our parent function. So this is the f of x, absolute value of x. Now we are going to look at our g of x, which means that it's plus 3. So we're shifting vertically upward by 3. So 1, 2, and 3. There's the first point, and there's our other points. Yes, we could, again, do a table and calculate the points to make sure that we're doing it correctly. Um, there we go. Now that kind of, this side failed. Oops, and then I'm erasing both of them. That did not look correct at all. Or was it the original one that did not look correct? Oh, come on. It's such a little movement here with this thing. The ruler, well, that's not, okay, we'll take that. So this one here is not f of x, it's the g of x. Absolute value of x plus 3. Okay. Now, next, what we're going to look at are the horizontal shifts. So notice the difference between this now. The plus c is inside the parentheses. And this is when the graph of y equals f of x is shifted c units to the left. And this is kind of, we think about plus and moving it right, but it's actually moving it to the left. Um, the horizontal shift y equals f of x minus c is the graph of y equals f of x shifted c units. That is to the right, even though it is a minus. Um, um, so again, if when and notice again, it's both of these are inside the parentheses, um, like with the x, so it's done to the x. Okay, so let's look at the graph here. We have a square root, a parent function is square root of x. So we're going to go ahead and do the table so that we know what we're graphing. So if x is 0, it's going to be a square root of 0, which is 0. So it's right here. And remember, it's going to be positive numbers because um, we can't have a negative square root. So 1, x is 1, um, y is going to be square root of 1, which is 1. So 1, 1. Now, we can do square root of 2, but that's going to be a decimal. It's going to be hard to, plot over here accurately. So we're going to take the next perfect square. We're going to do square root of 4, which is a 2. So 4, 1, 2, 3, 4, 1, 2 is over here. So our parent function looks somewhat like this. Okay, next, we're going to go ahead and do the g of x, which is, this should be g of x, which is this. So square root of x minus 4. So we're plugging in 0, 0 minus 4. That's going to be a square root of negative 4. Well, that's not going to work. Because that's going to be a 2i, imaginary number. So what we need to do is we're actually going to have to start with the 4. 4 minus 4, that's going to be our 0. So you can see that it shifted 1, 2, 3, 4, 0. It is shifted 4 to the right, which this tells us also that that's what's happening. Everything else should be the same. So if we do, x as 5, and we do 5 minus 4, that's going to be a square root of 1, which is 1. So that's going to be up here. And then for 6, 7, we need an 8. 8 minus 4, square root of 8 minus 4 is going to be square root of 4, which is a 2. So hold on, 1, 2, 3, 4, 5, 6, 7, 8. And you can see that we shifted it 4 to the right. Shifts 4 to the right. sorry. Um, sh excuse me. G of x shifts 3 up. This one shifts 4 to the right. Okay. Next, we're going to look at reflections of graphs. So reflections about the x-axis. So the graph of y equals negative f of x is the graph of y equals f of x reflected about the x-axis. So f of x equals square root of x. If we reflect it, it becomes g of x equals negative square root of x. Reflection about the y-axis. So the graph of y equals f of negative x is the graph of y equals f of x reflected about the x-axis. So if our original f of x is still square root of x, our reflection about the y-axis is going to be square root of negative x. Okay, let's look at an example. We're going to graph the cube root of x here. So x and our y is cube root of x. Now, we're going to start with the 0. That's going to be a 0, so it does go through the origin. The other values, though, we're going to have to look at a cube root of x. Well, 1 cube root of, actually, the other way around. 1 cube root of 1 is going to be 1, so that's still a 1, 1. And negative 1 is the same thing. A cube root of negative 1 is going to be negative 1, so it's going to be right here. But next, we should 2 cube root of 2 is going to give us a decimal number. The next one is going to be cube root of 8, because cube root of 8 is a 2. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 1, 2 over here. And negative 2, cube root of negative 2, I'm sorry, negative 8 is going to be negative 2. So 1, 2, 3, 4, 5. I'm getting lost here. 1, 2, 3, 4, 5, 6, 7, 8, and 2 right here. So it looks something like this. Our f of x equals cube root of x. Okay. Hold on. F of x equals cube root of x. Okay. Now we are doing a reflection. And here's the thing. The reflection, as you can see, the negative is inside the cube root. So that means that this is a reflection about the y-axis. And what we can do, so what's going to happen is that it's reflecting about the y-axis. So there's one option for us to just reflect it about the y-axis. So like this point goes here, and this point goes here, and then this point goes over here, and this one goes here, and it's going to be like, look like this. Our other option is just to do the table and plot the points. but this negative inside tells us that it is a reflection about the y-axis. Okay, next one is going to be vertically stretching and shrinking graphs. So let f be a function and c a positive real number. So if c is greater than 1 and the graph of y equals c times f of x is the graph of y equals f of x vertically stretched by multiplying each of its y coordinates by c. Now, if c is between 1 and 0, so that means a decimal or a fraction, anything between 0 and 1, the graph is going to be vertically shrunk by multiplying each of its y coordinates by c. Okay, in this next example, we are vertically stretching. And this should be g of x because the number is 2. So it's greater than 1, and that means that we're stretching. Okay, we already graphed the absolute value function. So we know we've done the table. So we know that it looks something like this. I'm not going to spend time on the kind of just sketching it right now. Now for the g of x, so we already figured out that we are stretching vertically by 2. So y equals 2 times absolute value of x. So if we start from negative 2, 2 times the negative 2 is going to be 2 times 2, which is 4. So negative 2 and 4, 1, 2, 3, 4, somewhere here. Negative 1, 2 times negative 1. So 2 times 1 is going to be 2. So negative 1 and 2. 0 is going to be 2 times absolute value of 0, which is 0. So that's origin. And then the same thing for 1 and 2. So 1 is going to be 2 and 2 is going to be 4. And you can see that it is like the points are the points are vertically stretching. Okay, next one. We're going to go ahead and horizontally stretch and shrink. Here. So let f be a function and c a positive real number. So if c is greater than 1, now notice that the c is inside the f of x. The graph is horizontally shrunk by dividing each of its coordinates by c. Or another option is multiplying by the reciprocal. So flip the number over. Okay, if c is between 0 and 1, the graph y equals f of x is horizontally stretched by dividing each of its coordinates by c. This line should be over here. Okay, so let's look at a graph. We have the parent function is f of x equals x squared. Y equals x squared. So negative 2, negative 1, 0, 1, and 2. Negative 2 squared equals 4. Negative 1 squared equals 1. 0 squared equals 0. 1 squared equals 1. And 2 squared equals 4. So our first point is negative 2 and 4. 1, 2, 3, 4 right here. Negative 1 and 1, 0, 0. And all these should be like symmetric for the quadratic function. So this is the parent function, f of x equals x squared. Now, if we look at g of x here, g of x equals half times x squared. And actually what we're going to do here is we're going to bring the 2 outside. So g of x equals half x squared. So the half is in here with the x. So that means that this is stretched horizontally. Y equals half x squared. 0 is going to be a 0. We're going to do 2, which is half times 2 squared. So 1 squared is 1. And then we're going to do 4. So half times 4 squared, that's going to be 2 squared, which is 4. So 0, 0, 2, 1, 2, 3, 4, 1, 2, 3, 4 over here. And we can plot the points on the same 3, 4, 1, 2, 3, 4 on the negative side as well. So as you can tell, it is vertically stretched. So this is the g of x, half x squared. Okay, now what we're going to do is we're going to go ahead and use the graph of f of x equals x squared, so the quadratic function, to obtain g of x. As we can see, there's several transformations here that we're going to have to follow and go through. If we look at what all is on here, is that we are this number 2 in front, we are stretching by 2 vertically. The plus 3 here means that it's going up 3, and the minus 1 means that it is going right 1. Okay, here's the thing though. There is a order that needs to be done when we are doing these. The order of transformations has to be followed. So let me write down order of transformations. So first, you're going to do the horizontal shift. Second, you are doing the stretching and shrinking. Third is going to be any reflection, so if there's a negative. And 4, it's going to be vertical shift. Okay, so horizontal shift first. before we actually do anything, we need to do the original or graph the parent function. We just did it. Hold on, that's not where that goes. 1, 2, 3, 4. 1, 2, 3, 4, right here. Okay. So the original parent function looks somewhat like this. We're going to go ahead. So first is the horizontal shift. So we are shifting this whole thing right 1. So this point goes here. These, everything shifts right 1. Next, we are doing or 2 is stretching and shrinking. So we are stretching it vertically by 2. So that means that each point goes, the 0, 0 doesn't change, but each of the other points, so like this point 1 goes, we double it by 2 to get 2. Same thing here. This one here is going to go 1, 2, 3, 4, 5, 6. I guess we'll be out of the, because that's going to be an 8 because it's a 4. 4 times 2 is 8. So this is kind of what it looks like after the stretch. And then we don't have any reflections. We don't have any negatives here. And we're going to vertically shift up 3. So 1, 2, 3 is up here. Then the next point, 1, 2, 3. So what I'm doing is I'm counting from the points up 3. 1, 2, and 3 is up here. And then the next point is going to be out of the, because that just keeps going and going. Somewhere up here. Um, it actually should be. That's what's bothering me right now, is that it should be the same shape. Well, no, because it does go up, so it's yeah. So that's your lesson on transformations. Let me know if you've got any questions about it. Bye.